Get the absolute value, and the absolute value of x equals 10 meant that x was 10 or x was negative 10, right? If I put something in with the x, that means x plus 3 equals 10, or x plus 3 is negative 10. So when I have an expression inside the absolute value bars, instead of just a variable, I end up with two equations that need to be solved, rather than just two answers. I'm still going to get two answers, but I'm going to have to do some work to get there. So the first thing, stepwise, you do is you isolate the absolute value expression. And we do that by first adding or subtracting outside. And then we multiply or divide by what is outside. After we've got that absolute value expression by itself, so it looks like this, we have to split the expression into two equations. So we split our current equation So we take that one equation that has absolute value and we return it into two equations that don't. One equal to a positive, one equal to a negative. Okay, right? So I have a positive and a negative. And then we solve it. Now, just like absolute value of x equals negative 10 had no solution, if I have any kind of absolute value is equal to a negative, even if it's a full expression, there's still going to be no solution. Okay, so we can only split it if it's positive. If it's negative, it's still no solution, just like it was last time. I need to get this by itself, the absolute value by itself, so I'm going to subtract 5 from both sides. Okay, which gives me the absolute value of 2x minus 8 is equal to, let's try 1 minus 5, 16. Okay, now I have the absolute value by itself, and this is still positive, so it's solvable. This is when the split has to occur. I'm going to turn that one equation into two. Okay, so I take whatever is inside of this absolute value and pull it out. And then I take this positive and negative. Now remember, when you have absolute value in your equation, if there's a variable inside, you're always going to have two answers. When it's a variable by itself, we got a positive and minus of the same number, but when it's like this, we're going to get two separate answers. So now we solve each of these. So I'm going to add 8 to each side here, and I get 2x equals 24. Divide by 2, x equals 12. Add 8. 2x equals negative 8. Divide by 2, x equals negative 4. So you see I'm doing the same steps on both, but because of the difference here and here, I'm getting two different answers. Then you can just write the word or in between them, and you can do that. Now I'm going to show you this next one, and then I want to show you another way you can solve these. but I don't want to confuse you. So when we get to this part, I've got 2 times this absolute value. And remember I said you can't distribute in, right? It's like a wall, you can't go in, so we have to divide both sides by 2. So I have the absolute value of 2x plus 4 equals 10. So again, if I have positive 10 absolute value, that's 10. And if I have negative 10 absolute value, that's also 10. So this right here could be 10 or negative 10. That's why we have to split, because I don't know which one it is. So I'm going to do that split. So 2x plus 4 is 10, or 2x plus 4 is negative 10. Because I don't know which one it was. I'm going to subtract 4 from both sides. And I get 2x is 6. Divide by 2. And I get x is 3 here. If I subtract 4 from both sides there, I get 2x is negative 14. Divide by 2. And I get x is negative 7. So I get 2 answers. Yeah?
Why did you divide it by 2 on both sides?
Here, because it's 2 times x. So I need to know what 1x is. I have to divide both sides by 2. Yeah. No, we can't. Oh, up here. Yeah, I can't distribute into the absolute value. You can't ever go in to absolute value. You can only come out. Once I get to this point where I've got the absolute value by itself, you know, in the first example, I said, okay, we're going to split it, and you got 3x plus 6 equals 12, and 3x plus 6 equals negative 12. So you can write it like that, or you can write it like that. If you do this, though, whatever I do to both sides here, I'm actually going to have to do to 3 places. I need to do it to both sides, but I have 2 things happening on the second side. So if I subtract 6, I have to subtract 6 here, here, and here. Okay. So I get 6, and I get negative 18. And then I divide by 3. So if I'm dividing by 3, I have to divide all of them by 3. And if we come over here, you can see that I'm going to end up with the same thing. It's just which one makes more sense to you. They're both the same.
This one seems a lot easier.
This one over here or this one here?
The way you're doing it now.
The combined?
Yeah, because I didn't understand why you had to divide by 2.
Oh, well.
You have to divide by 2 every time, or?
No. If there's not, like right here, I didn't have anything to add or subtract or multiply or divide. If this had been like this, I would have had to divide by 3. Because I have to get the absolute value by itself first.
Oh, so you're not even doing anything with the division. I mean, with the absolute value.
Not until.
Oh, I thought you were dividing
up
the
here.
Absolute value by 3 also.
No.
Like.
Oh, no. I was just dividing the 2 away
Like,
over the whole thing.
Yeah.
Yeah. So if I went like that, would it have been better?
Yeah.
Okay. Yeah, no, I'm trying to get the absolute value completely alone before I split it. And then I can either split it into 2 separate equations like we did initially, or I can write it as one compound equation. Like this is kind of a compound equation. Your compound sentences have and or. This is a compound equation. I have an or in there. Does that make sense? So I'm going to make my eraser bigger. I'm going to do the same thing again. I can either split this into 2x minus 3 equals 10, 2x minus 3 equals negative 10, right? Because this inside has to be 10 or negative 10. Or I can write it as a compound and put that together. What was that? Okay. So here I'll add 3. Just remember, if you do it as a compound, you have two things on the on the other side that you're having to add 3 to or divide by whatever. You want to make sure you account for everything. So I get 2x equals 13 or negative 7. I'm going to divide everything by 2. And those don't divide, which is perfectly fine. And I'm just going to leave them as fractions. Absolute value of 5x minus 1 equals negative 8. We can't have this situation, right? Absolute value is always positive. So no solution. Here I have a negative out front. So this is negative. I'm going to basically divide both sides by negative 1 to get rid of it. And now I can solve it. I can either split it into 2 equations, or I can do the compound. Okay, so either way, if I've split it, I'm adding plus 8 to both sides. Dividing by 4. And if it's compound, it's the same steps, right? I'm adding 8. I just have to do 3 instead of 2. And then I'll get the same answer, 8 or negative 4. Can you guys see that I'm dividing by 4 here? And then that'll give me the same answer. If we talk about a ratio is just a comparison. That's too fat, isn't it? A ratio is just a comparison of two values. That's all it is. It can be written like 2 to 3, 2 to 3, or 2 to 3. This is, like 2 cats for every 3 dogs or something. It can be anything. It's just comparing numbers. A proportion is when you have 2 ratios that are equal. For example, 2/3 is the same thing as 4/6. So ratios just compare two values, proportions compare two ratios and say they're equal. So far okay? So there's 2 ways to decide if 2 ratios are proportional or not. The first way is to take the simplest forms. 2/3, this is already simplified. Okay, so I'm going to take 16 over 24 and I'm going to simplify it. 16 and 24 both divide by 4, right? So if I divide by 4 to the top and the bottom, I would get 4 over 6, which would then divide by 2, and I'll get 2/3. 2/3, 2/3, they match, so it is a proportion. Same, I have 6 over 10 and 12 over 5. Okay, if I have two ratios and the large number is on the bottom in one and the large number is on the top in the other, there is no way that these are going to match and form a proportion. But I'll go ahead and simplify this one. That would be 3/5. 3/5 and 12/5 are not the same thing. So no. Make sense? Okay, 1/6 and 5/30. 1/6 is already simplified. 5 and 30 both divide by 5. I get 1/6 and 1/6. So yes. So the first way you can tell proportions, or if two ratios make a proportion, is to simplify the fractions. And if they match, you're good. But maybe you don't like simplifying fractions. Property of proportion. And I'm going to show you what that means. If A over B is equal to C over D, if these two things are equal, then AD is equal to BC. It's cross multiplying. Okay, so what I do is I'm going to take A times D and B times C. And if those two things are equal, then I have a proportion. So if I do, I'll just rewrite it so they're kind of farther apart. If I take 3 times 16 and 2 times 24, 3 times 16, 2 times 24. 3 times 16 is 48. 2 times 24 is 48. These are equal, so this is a proportion. Well, we have already done all these, but we'll just keep going. If I cross multiply these, I have 10 times 12 and 6 times 5, so I have 120 and 30. Those are not equal, so it's not a proportion. One times 30, 6 times 5, 30, 30, they are equal, so it is a proportion. What's happening here is you're being told that these two, this is a proportion. These are equal. So what you want to do is you want to cross multiply. 5 times x is 5x, and that's going to be equal to 3 times 10, or 10 times 3, it doesn't matter. So 5x is equal to 60, wow, 30. Divide by 5. See, in my head I was thinking 6 already, so I said 60. X is 6. It'll be the same thing here, except instead of being 7x, I'm going to have 7 times x minus 2. Because I have to multiply this entire quantity times the 7. And that'll be equal to 2 times 14. So I'm going to distribute that 7. 7x minus 14 is equal to 28. Add 14 to both sides. 7x is equal to 42. Divide by 6. Divide by 7. Guys, don't let me get away with this. I keep saying the answer before it happens. So I divide both sides by 7 and I get the answer is 6.
So if you, if it's not like even basic now?
No. You can, You could just get a fraction, yeah. I'm going to cross multiply. I get 8 times r plus 4 is equal to 3 times 5. Distribute that 8. 8r plus 32 is equal to 15. Subtract 32. 8r is equal to negative 17. So here we're going to have that exact situation, Madison. If I divide by 8, it doesn't divide evenly, right? A lot of real-world applications. We can use it for rate of growth. You can use it for scale modeling, things like that. So we have in the past 2 years, a retailer opened 232 stores. Okay. This is a comparison of two quantities. This is a ratio. 2 years, 232 stores. If we want to know if the rate of growth remains constant, how many stores are going to open in the next 3 years? Okay, well, in the next 3 years, that's years, years. If I have years on top, if I do years over stores, it has to be years on the top on both sides. Does that make sense? I can't put years up top here and then years in the bottom here. So 3. I don't know how many stores. So that's x. I cross multiply and I get 2x is equal to 3 times 232. So 2x is equal to 696. Divide both sides by 2. $348. Oh, that's not per year, sorry. So in the next 3 years, 348 stores should open. Do you want minutes on the top or numbers of time on the track, around the track on the top? Because it doesn't matter. Minutes on top, so I'm going to do 7 over 2. How many times can she walk around the track in half an hour? How many minutes is that? So 30 over x. Cross multiply it, I get 7x is equal to 60. Divide by 7. Doesn't go evenly. So it's 8 and, hold on. Was that 56? So 4/7 is how many times, yeah, or 8.57 times around the track. Good? The last kind of real-world application that we're going to go over is scale model. Scale is when sizes are proportional. Okay, so if I have a cup and I shoot it with a shrink ray, it'll shrink down, but it'll still remain the same proportions. And a scale model is a smaller or larger proportional model. You guys have seen those like the buildings when the architects are showing like on TV? That's a scale model. So they're to scale. So what we would do is if we have a map and 3 inches is 10 miles, 1 1/8 inch. I'm trying to remember what that decimal is. Not 4, 2. 1.125 over x. So I get 3x is equal to 10 times 1.125. So 3x is equal to 11.125. 0.25. Divide by 3. And, you know, this would obviously be easier with the calculator, but I'm not feeling like it. So 3.75 miles. Make sense? Okay. All right. Homework. In the packet, I had it marked. Hold on. Page 3 and 4, 5, 6, 7, and 8, every other odd. Okay, so you guys remember, do 1, skip 3, do 5. Okay. These two are the absolute value, and then all of these are proportions and ratios.